Hello friends. In this session, we are discussing regarding the last part of the unit 3, which is floods and flood estimation. Now, in this session, especially we'll try to understand what are the floods, concept of design flood, calculation of peak and flood discharge. Now, this a flood is an unusual high stage of river due to runoff from rainfall and or melting of snow in quantities too great to be confirmed in normal water surface elevations of the river or stream as a result of unusual meteorological combination. Okay, so friends, you can know that. So because of the runoff or occurred, so sometimes the flood will occur there. Okay, it is measured from some year. So the flood levels are fixed for any river or any stream. So accordingly, the constructions have been also carried out. So depending upon the flood level record earlier in that area. Now because of the flood, what will happen? The all the area, or you can say that particular catchment, that is you can say saturated because of this water, and water flows over the surface of the earth. Now design flood. What is design flood? The maximum flood that any structure can safely pass is called design flood and is selected after consideration of economic and hydrologic factors. The design flood is related to the project failure. For example, the spillway design flood that may be much higher than the flood control reservoir design flood and the design flood adopted for the temporary copper dams. Now you can see in the figure again you can see this here the 100-year flood plan has been shown here, base flood, and the floodway is also mentioned in the figure. So you can see, so accordingly these constructions have been carried out, right? And depending upon these flood lines are also known to because of the record. Now, a design flood is selected by considering the cost of structure to provide flood control and flood control benefits. The benefits can be categorized into direct and indirect. Direct, or these are called tangible benefits, prevention of damage to structure downstream, disruption, communication, loss of life and property, damage to crops and underutilization of land. Okay, so these are the important points there. Indirect and intangible, the money saved under insurance, the workman's compensation laws, higher yields from intensive cultivation of protected lands, and elimination of losses arising from uh, interruption of business, reduction in the diseases resulting from the inundation of flood waters. When the structure is designed for a flood less than the maximum probable, there exists a certain amount of flood risk to the structure, nor is it economical to design for 100% flood protection. Protection against the highest rare floods is uneconomical because of large investment and infrequent flood occurrence. So always we have to take the care when you are constructing the any structure, so that there should not be harm to the structure. So design flood plays important role in that. Now standard project flood SPF. This is the estimate of the flood likely to occur from most severe combination of meteorological and hydrological conditions, which are reasonably characteristics of the drainage basin being considered, but excluding extremely rare combination. Then maximum probable flood MPF. This differs from the SPF in that it includes the extremely rare and catastrophic floods and is usually confined to spillway design or very high dams. The SPF is usually around 80% of MPF for the basin. Okay, so the last statement is very important. Okay, how the on the safer side it is work, that SPF is usually around 80% of the MPF, that is the maximum probable flood of that basin. Then design flood, it is the flood adopted for the design of hydraulic structures like spillways, bridge openings, flood banks, okay, etc. Estimation of the peak flood. The maximum flood discharge, peak flood in the river may be determined by various methods, physical indications of past floods, flood marks and the local inquiry, empirical formulae and curves, concentration time method, overland flow hydrographs, rational method, unit hydrograph, flood frequency studies. Now, estimation of the peak flood, the physical indications of the past floods, the flood marks and local inquiry. By noting the flood marks and by local inquiry, depths, affluxes, heading of the water near bridge openings or similar obstructions to flow which are called as affluxes, and other items actually at an existing bridge or weir in the vicinity, the maximum flood discharge may be estimated by use of Manning's or Chase's equation. Okay, so this you have studied in the fluid mechanics. So if you know the flood marks, so it is always better for the construction and the safety of the structure as well, which are already existing there. So empirical formulae and curves are there. So there are plenty empirical formulae related to the discharge with the drainage area A in the basin. So I will just read the names of the formulae. So which are available here. In that the Berkeley-Ziegler formula is there, Dickens formula, Rives formula, English formula. Okay, so many formulation is there where this discharge can be worked out, right? So okay, I will read this Q Berkeley-Ziegler formula, that Q is equal to, okay, 4 by 2 A raised to 3 by 4. So then Dickens formula is Q is equal to CD into A raised to 3 by 4. Rice formula is Q is equal to CR A raised to 2 by 3. Then English formula is Q is equal to 124A divided by bracket A plus 10.4 raised to 0.5. So as the name indicates, these are the empirical formulae where Q is the peak flood in meter cube per second and A is the area of the drainage basin in kilometer square. CD and CR are the Dickens constant and Rives coefficients respectively. Now estimation of the peak flood can, the third one is the envelope curves. Okay, so areas having similar topographical features and climatic conditions are grouped together. All available data regarding discharges and flood formulae are compiled along their respective catchment area. Okay, this is a record of the similar flood regimes, remember, or these envelope curves are there. So this is the envelope curve which is plotted, okay, on a semi-log paper, which is against on x-axis catchment area and on this maximum flood discharge is there. So these for the similar areas, this particular curves are studied and the estimation of this peak flood can be obtained. Okay, so there is a uh, you can say the study is behind this and record is necessary. Also availability of the similar area, the information must be necessary there. Next is the rational method. The rational method is most effective in urban areas with the drainage areas of less than 200 acres. This method is typically used to determine the size of storm sewers, channels and other drainage structures. Rational method is based on the application of the formula Q is equal to K into CIA, where C is the coefficient depending on the runoff qualities of the catchment, called the runoff coefficient, generally 0.2 to 0.8. A is the area of catchment, I is the rainfall intensity, and K is the conversion factor. Now in for English units, the occurs in inches per hour. K is 1.008 to give the flow in cubic feet, and SI units of hectares, millimeters per hour. K is 0.00278 to give the flow in meter cube per second. So we'll have to remember when we'll have to use this 1.008 and when we'll have to use this 0.00278. Further, this I is equal to the design intensity or critical intensity of the rainfall IC, corresponding to the time concentration TC for the catchment for a given recurrence interval T, also called as a return period. Okay, so that we have also studied earlier as well. So this IC can be found from the intensity, duration, frequency IDF curves for the catchment corresponding to TC and T. Okay, so this is a typical intensity, duration, frequency curve, which is called as a IDF curve, which is plotted against duration and the intensity in centimeter per hour typically for this. Now these are plotted for the typical years. You can see the these color coding is also given here, right? So this blue stands for the, you can see, for 25 years. This red color stands for the 50 years, and this stands for the black stands for the 100 years, right? So such a typical intensity, duration, frequency IDF curves, those are important. If intensity, duration, frequency curves are not available for the catchment and maximum precipitation of P centimeter occurs during the storm period of TR hours, then design intensity I, that is equal to IC, can be obtained from the empirical formula as given here, that IC is equal to P divided by TR into bracket TR plus 1 divided by TC plus 1 bracket complete, where the time of occurrence TC is not known and that IC is equal to P divided by TR. Okay, so typical terrain, so these values can be worked out for this particular C. Okay, so for depending upon the terrain, that particular value differs. So we have to remember this particular method to calculate this IC. Further, time of concentration, it is defined as the time needed for water to flow down from the most remote point in a watershed to the watershed outlet, right? So you can see here from a more distant point, okay, from that the water will flow and comes towards the outlet. So that is a time which is defined as the time needed for the water to flow from most remote point to the watershed outlet, you can say. The time of concentration equals the summation of the travel times for each flow regime along the hydraulic path and hydraulic length, right? So the formula is given as this time of concentration TC is equal to, in bracket, L by V1 plus L by V2 plus L by V3, likewise so on, depending upon how many these hydraulic or flow regimes are available there. So hydraulic length is the distance between the most distant point in the watershed and watershed outlet. Estimation of peak flood, in that this Kirpich formula is used, okay, which is TC is equal to 0.0078 L raised to 0.77, s raised to minus 0.385, where this Tc is equal to time of concentration in minutes, L is equal to maximum length of flow in feet, S is equal to the watershed gradient of feet per feet, or the difference in elevation between the outlet and the most remote point divided by the length L. So these are the various methods of flood estimation, and also it is necessary to understand all these flood formulations, various methods which are available to calculate the flood in that particular area. So thank you very much friends for joining this session.